A sender S sends a message M to receiver R, which is digitally signed by S with its private key. In this scenario, one or more of the following security violations can take place. 1. S launches a birthday attack to replace M with a fraudulent message. 2. A third-party attacker can launch a birthday attack to replace M with a fraudulent message. And 3. R can launch a birthday attack to replace M with a fraudulent message. Which of the following are possible security violations? So this is a question from computer security regarding birthday attack. So a birthday attack is a very interesting computer security violation. So what happens in birthday attack is there will be a sender and a receiver. Suppose a sender and receiver are trying to make a contract between each other so that they both want to sign the same contract. So a sender will make a message M, and then the sender will take the hash function of this M, which will be H of M, and then it will sign this message with the sender's private key, which will be S of hash of M, and this will be sent to the receiver. So the receiver will have this message and the hash and also the signature signed by sender. Now the receiver can use S as public key, and then using that it can decrypt this and get hash of M back, and it can see that it was actually signed by the sender S, and the receiver may further sign it in order to close the contract. Now suppose sender has a fraudulent message M dash also, which he wants to send to the receiver. Now he will find out the digest for this message H of M dash, which is equal to H of M. So he needs the fraudulent message M dash and the actual message M, which both has the same message digest hash of M. How this can happen is when we are forming the hash of a message. See, this is a message space which will be very large, which we are compressing to a hash space. Now the hash space will be smaller than compared to the message space, meaning there will be multiple messages here which has the same hash function. So how a sender can find out M and M dash using which are having the same hash function is that the sender will have a message M, that's it, it will have a fraudulent message M dash, and the sender will keep on trying to change a few letters here and there, or it can change spaces, he can add commas etc. in M and M dash, such that the meaning of both doesn't change, but then on making each change the hash function will change. As the message is changing, the meaning is not changing, but the message will change and the hash function will also change, meaning he can keep on trying making small changes in M and M dash such that he will arrive at two messages M, M dash, such that both has the same hash function. After he does this, he will take this message and obtain the hash and sign it and then send it to the receiver. Now after the receiver also agrees to this message, he can take the fraudulent message M dash and then get the hash and then sign it. So this signature S of H of M dash and S of H of M will both be same, because hash of message and hash of M dash, the fraudulent message, will be the same. Now at a later stage, S can show this message and show that this is the hash of this message, and then get the signature and show that this was a contract actually sent to the receiver. At a later stage, he can say that receiver signed the fraudulent message M dash instead of this M. So this is birthday attack. Now let us look at the options. 1. S can launch a birthday attack to replace M with a fraudulent message. That's correct, that's what I showed just now. A third-party attacker can launch a birthday attack to replace M with a fraudulent message, and R can launch a birthday attack to replace M with a fraudulent message. Now for a birthday attack to take place, clearly this signature part S of H of M has to be there, but in order to sign this, we need to know S's private key. Only with the sender's private key can we sign the hash of a message, and only once we have the signature we can decrypt it and show that a sender has actually signed a message. For a third party attack or the receiver to get S to sign a different message, obviously S's private key has to be known, which a third party attacker or the receiver doesn't have. So the receiver or third party attacker cannot launch a birthday attack as they don't know S's private key. So these two are false, only one is correct. So option B is the right answer.